I'm Matt Swartley with Chariot Solutions, and I am pleased to introduce you to Drew DeCarme, who is a coworker of mine at Chariot. Drew's title is front-end engineer, but he's really the go-to person at Chariot for all things front-end, including architecture, scalable design patterns, and everything to do with CSS. Today, Drew is going to share a portion of his vast front-end knowledge, including the practical application of a few key HTML and CSS fundamentals that will convince us that we do not, in fact, need that component library. So please welcome Drew DeCarme.
All right, thanks, Matt. So like Matt said, the title of my talk today is called Trust Me, You Definitely Don't Need That Component Library. But first, since I do work at Chariot, we have to talk a little bit about Chariot. So believe it or not, this year is our 20th anniversary. So that's pretty incredible. If you're here, you most likely know what we do, but I'll cover it anyway. We're an expert consulting firm that specializes in pretty much all walks of software development, from the front end to the back end, all the way up to DevOps. And as a shameless plug, we currently are hiring too. So if you're definitely interested, please head on over to our careers page, and we'd love to hear from you. So like Matt said, who am I? I'm Drew. I'm a front-end engineer at Chariot, and I specialize pretty much in all walks of software engineering on the front end. So that's build tools, configuration, architecture, CSS, definitely one of my fortes, accessibility, semantic markup, all of that, right? So I've been writing large scale front end. I'm going to call them systems because it's much more than just an application for probably about 12 years now. And it's one of those things where my career has progressed as the front end landscape has kind of progressed. So it's been like a wild ride, and it's only going to get more insane as it goes on. So I'm here today to talk to you a little bit about understanding some of the insanity inside of our space, and that is third-party component libraries. All right, so why the talk, right? These things exist for their use. Like, why can't we just accept it and move on? So in order to answer that question, I want to talk about a small scenario. So let's say that you're from the United States, right? And you go on vacation to a place that you have known from time to time to have some sort of contaminated water or food poisoning, right? So you're out on an excursion, you're out away from the hotel, and you realize that you forget your water bottle and you have no water and you're absolutely famished and you're thirsty. So you and your group, you come across a questionable looking establishment that has running tap water. What's your next move? So much like a lot of your decisions that you make, the answer is not really straightforward. It's all based upon context. How thirsty are you? Have you not had water in the past 20 hours, or is it just like an hour? Is the water brown? How long away are you from ending your excursion? Is the hotel close? But, as you start to weigh these different things, you start to realize that you should have just brought your own water bottle, right? You could have avoided all of these different things. So let's take a look at that scenario. I know it's a bit contrived, but, let's look at a little bit of a different angle to this problem. Let's put a name on that building. All right, so we'll call it Casa de la NPM. Does the fact that it now has a name change your decision-making now that you know the context behind what you're actually getting into, right? So your first instinct is to go in and rush and drink the water, but are there other alternatives? Much like JavaScript engineering these days, your first instinct to come across a problem is to go and look at the NPM registry, but there's context to it, right? How many lines is it? How complex is it? Who's maintaining it? Is it backed by an organization, or is it backed by a single person? Is it actively maintained? There's all sorts of things that go inside of a decision that could make or break, what your next moves are. So what I really want to say is that we've gotten to a point, especially in JavaScript, where our first knee-jerk reaction is to go and check the registry. So I think we're really foregoing our good sense by just checking for a solution that someone already created, and not evaluating what we're actually putting inside of our applications. So I think it's time we take a couple steps back and really think about it. So a couple of points. First, the unknown complexity can really kill your project, right? Tribal knowledge, local shims, things of that nature, and making any sort of technical decisions that aren't aligned, or that go with the pattern library, or go with the component library, may not be aligned with the actual overall product vision that you have, right? App weight's always been a problem. 300, 400K of JavaScript served to a client app is something that we kind of deal with. But as more factors are added into it, like site complexity and accessibility and index ranking, those detriments can really equate to real dollars. And then I think right now we're in this period of, I would say, extreme enablement, where you can pretty much do anything regardless of what your area of expertise is, right? So I'm a front end engineer. I know nothing about services. I know nothing about load balancers, but I can get on Netlify and I can deploy an app out and have a service app, no problem, using Jamstack technologies. I can do the same thing with Amazon. It's a little bit more convoluted, but I mean, that's good in a sense of getting things out. But when it comes down to scaling certain things and scaling your application and making sure it's robust and that it has a lot of checks and balances in it, I think we're actually kind of bolstering laziness. We're not really understanding some of the core technologies behind what we're doing, especially on the front end. And we're kind of like pushing away from specialists, and we're good at creating more generalists. So I think one of the biggest offenders is third-party component libraries. So here's what we're going to talk about. And I'm going to cruise through these slides because I want to spend most of my time actually in a code editor. So we're going to talk about why they're used. We'll talk about some of their downfalls quickly, and then we'll also talk about some of their actual good uses. And then we're going to create a component library ourselves. I'll touch on some best practices. I'll dispel a couple of myths, and we'll just get the writing some code. All right. So front end development right now is a lot more than just DOM nodes and HTML. So from my perspective, any greenfield project, this is kind of what we're looking at in 2022. We're looking at almost a self-fulfilling prophecy. We want to get to the top, but we have absolutely no idea how to do it. And, we're kind of in our own way. So we as front-end engineers, we have to deal with tools and build systems and different methodologies for organizing your code and different frameworks that do different things. Solid, server-side rendering, client-side rendering, server-side streaming just came out. Like it's gotten to a point where it's mind-numbing and it's hard to make sense of it. So you don't really know where to start. So let's make it a little bit more real now, right? So I'll walk quickly through this, but these are kind of all the decision points that need to be made when you're actually starting a front-end project. It's not so easy these days. So you choose a library, and then you go and you have to choose a framework. We have Remix, we have Next.js, which does server-side rendering. We have Gatsby, which is fully client-side, static site generation. Like it's insane, So we have to choose a framework to first regulate our library, and then we have to choose either a framework or a methodology of actually styling our application. Or we're going to use CSS and JS, or we're going to use Sass, or we're going to use Less. Nobody uses Less, but I guess it's kind of synonymous with preprocessors. How are we going to organize our code? Are we going to use a monorepo? We're going to use a monolith. What kind of package manager are we going to use? We can't just use npm. There's Yarn, then there's Yarnberry, and then there's pnpm, and there's all sorts of other things too. And then I'm obviously not going to touch on like the holy war that is JavaScript versus TypeScript, but we have to understand how we're going to write our code. And then if we do have separate packages, how are we going to build and bundle those packages and serve them to our actual code? So by the time we get to actually saying, all right, let's write a couple components, I mean, I know what I am. I'm exhausted from this. I'm going to throw my hands up and say, screw it. We'll just use a component library. So, but that's just the tip of the iceberg, right? There's a couple other drivers for why we use these things, right? From the organizational side, timeline and bottom line, they don't always mesh up, and you have to make concessions. There could be some sort of principle or leadership bias. Someone could have a preference towards something that they don't necessarily want implemented in their tech stack. Legacy apps could pin you to lower versions of a library. And some people, whatever, it just works. Don't touch it, right? And then there's sort of technical factors too. And I see this a lot on the front end as well, where there's not a full grasp of understanding first of how to manipulate the DOM, and then actually how to organize the DOM, specifically with information architecture standards, right? So these component libraries make abstractions where I think they're not necessarily need to be made at that point, right? So I'll go back to my context point earlier, is that there is context to everything that we do. All right, a couple downfalls. I'm going to cruise through this. So libraries are very good at thinking of every single scenario, but for your use case, you don't need every single scenario. So would you actually take your kids to school in the DeLorean? Probably not, right? The DeLorean, it's sweet, goes back and forth between time, but do you really need, unless you're running late, do you really need a time machine to get your kids to school? Probably not, right? So that's the same concept. Do you need all the bells and whistles that a third-party component library has, right? You have to be very careful and look into the internals too of how that library is organized, because you may be weighing your application down unintentionally. Is it transpiled to CommonJS, or is it transpiled to ES modules? These are all sorts of things that you have to look into without just blindly saying install. And then obviously in the world of front-end development, size really does matter. The next thing is library shimming. So I think everyone's seen this before, especially kind of when Bootstrap came to popularity, where Bootstrap provided one thing, but you wanted to shim it to do something different. And then as you shimmed it more, other people shimmed it more. And then you had this sort of tribal knowledge and this application that didn't really build off of the principles that the other library had. So a good analogy would be, would you build a treehouse and then try to use it as a bunker? You could fortify it, bulletproof glass, extra joists. At the end of the day, it's still a treehouse. It's not a bunker. It's not going to survive a missile strike, right? So you're using something in a way that wasn't necessarily intended, and that could have like pretty significant impacts on the size of your app. I talked about trading away expertise. I don't think I need to touch on this anymore, but I think it's really starting to become more important as these frameworks progress, that we need to focus a little bit more on the fundamentals and not necessarily just on getting stuff out there. And there's some other notable detractors too. I won't go into too much. I'm going to send these slides out afterwards and you can read this on your own. But basically, we want to make sure that, we're not locking ourselves into a convention that we didn't decide on. We don't want to make this library our brain and then forego using our own brain. We're offloading the central form of intelligence of how our app is going to be styled and used. However, there are certain use cases for them. So rapid prototyping, that's amazing, right? Getting something out there, getting something usable, that's fantastic. Demonstrations, teams of less than 3. If design really hasn't been identified as a priority, or you have 0 design chops whatsoever, this is a good avenue to go down, right? But the thing that these all have common is the fact they're all using a limited scope. They all have a limited scale. All right, so we're sold. What do we want to accomplish, right? For the first need that we want is we want to create a small, reusable piece of code that follows a style guide. So we want to have a button that is styled the same everywhere we use a button. That's kind of self-explanatory. The next is that we want to be able to use that button in certain contexts and push and pull on certain levers and properties to make it work. So let's say you click on a button, you have a call that's loading and you want to show the button that's loading. That's the other thing. At its very core, that's it. That's all we really need as far as a component library goes. All right, so I'm going to switch over real quick. And hold on, let me get to the point. So let's build this component library. So I'm in my code editor right now, but we'll give some context. The first is we're going to be writing in React. I'm going to be using TypeScript because that's what I'm most comfortable with, and I think it's awesome. Again, I'm not going to touch that holy war. Setup and configuration for your own component library is very key, but I'm not going to be covering it. I pre-built the mechanisms around this. Honestly, probably I'll do a talk on configuring a library next year, just because there's so much nuance and there's so many places that you can go wrong. But I'll cover it really quickly, but I want to get more into the overall components. And we'll assume a greenfield project. We're going to be using a mono repo. And this could also be retrofitted inside of a monolith that you have. But for this case of argument right now, we'll start with a brand new repository. All right. So here's some basic rules. The first one, make sure that your component library is outside of the context of any consuming applications. So over here on the right, this is a mono repo convention. You have your app. I have 3 different applications, one written in Next, one written in Remix, and the other one that's written using Vite or that's built using Vite. Pretty much create React app, but a little bit faster with a lot less opinions. And then I have my components directory. At its very core, this is all you really need to do. And then you can move on. We just don't want to make sure we want to make sure that we're not making any hard linkages between our components and the applications that are consuming them. So when configuring the library, there's a couple things to keep in mind. Use a modern build system. So I used ES build, which is written in Go. There's other things that are written in, like SWC is written in Rust. Vite uses rollup. Snowpack uses like Dino-like URLs that aren't really downloaded to your machine. So it's a different flavor. Either or, they're all modern build systems. So we always want to build for 2 different targets. The first one is CommonJS, which is more popular with Node, just because it's a server-side library. And ES modules, which is becoming more prevalent both in client and server code, just because different libraries and different frameworks consume your modules in a different manner. Obviously, choose between TypeScript and ESDoc. Use a live documentation system. In this case, I'm using Storybook. Storybook is a sort of an isolated component development system. I'll show you in a second, that allows you to develop your components outside of the context of your app. It uses Webpack. So again, there's more configuration hell with it if you're using a separate build system. But again, like I said, you can't really get around configuration. You have to have it. Otherwise, it's just not going to work the way that you want it, because things have gotten so complex these days. And then obviously mind your package JSON. There's a couple of values inside of it that I want to like touch on, but I'm not going to go into too much depth because I want to get to coding some components. The main thing is that you need to have a couple of different keys inside your package JSON to tell any sort of consuming application where the code that you want to be served is. So for modules, I have it in a modules file. The convention is MJS, and in CommonJS, I have it in CJS. That's pretty much it, right? I'll get into a couple other things if I have time to, specifically around tree shaking. Unit test everything. Obviously, there's no unit tests in here. I know I'm a hypocrite, but didn't have time for that. And that's basically it. You know, getting down your configuration is core. And then once you have your development workflow, it's very, very easy to move forward and actually scale this thing properly. All right. So lastly, when writing your components, we'll keep it as simple as possible. You want to start at the most ridiculous base level you possibly can, which is also known as the atomic level. Buttons, inputs, icons, description lists. You want to get down to as close to the DOM node as possible. And then practice progressive enhancement around that DOM node. So I'm going to be talking about what I coined as DOM node inheritance. Don't look for that in the wild. It's something I made up, but I think it kind of explains what I'm trying to get after. And then assume the library needs to be isomorphic. So isomorphic is a really fancy word for saying it can work both on the client and the server. So don't import any, or don't make any references to like browser globals like document or window if they don't really exist. And then abstract only when you need to. So I'll cover all this stuff when I actually get ready. All right, so let's talk about buttons. So I'm going to create a button component. Actually, I'm going to refactor a button component, and I want to be able to use this button component the same way I would use an HTML DOM node inside my application. So I'll get my environment up and running. I will go to the button, move it over here. All right, so I'm doing a lot of things concurrently right now in one terminal. So, you know, if you have questions about that, I can answer those a little bit later. But basically, I'm running 3 different processes. I'm running the build system for the components, so the library can consume them. I'm running Storybook, and I'm also running the application in development mode. So I'm going to take the link that just popped up on another screen, paste it here. This is Storybook. All right. So we have our buttons and we have our variants. So on the left-hand side, this is kind of what you're used to seeing as far as a component goes. You have some sort of styled button, which, you know, we're using CSS and JS just to make it simple. I'm using a library called Lunaria, which I'll get to a little bit later if I can. So we have some style, we have some margins, we have different classes that denote which color they want. So if it's a contained component that has a primary color, we're giving a background color of whatever this blue is. And then here's the component, pretty straightforward, but we can't use this component the way we want to. And I'm going to talk a little bit about prop barriers. So I'm going to create a new component. So we'll do example. And when I want to add different props to it, I have the ability to see, okay, I can customize color, customize the variant, key and CSS are intrinsic to React. And then I can add children to it. But I can't use this the way that I normally would want to use a button inside the application. So there's a couple of things that we can do to refactor our button component to make it actually usable. The first is what I'm calling DOM node inheritance. I want to make sure what I'm using in the app is the same as what I'm using in the component library. So we can use a React mechanism called ref forwarding. So I'm allowing the component to be able to reference the actual DOM node that's underlying it. And we do it this way. So I'll do export const button, forward ref, I'll do function button. So props, ref, return, whatever this stuff is. All right, cool. So it's going to yell at us a little bit because it doesn't really know what we want. So we'll forward ref, we can use the power of TypeScript to kind of give a little bit better context of what this is. So we know that it's going to be an HTML button element. And we know it's going to take in button props as props. Then we can destructure our props with TypeScript using variant and color and children, and then do rest props. Use the spread operator to extract everything else out. Spread rest props on here. We'll give the ref, which is a button element, to the component, and boom. So what have we done? We've basically now allowed the application to reference the button. And so I'll go over here real quick. Get this. So now I could use something like const use ref, or we'll do button ref. We'll do button element, because it can be null. All right, cool. Everything works. TypeScript doesn't hate us. That's a good sign. But we still have this problem of this prop barrier. So where if I go to add more props, I can't really use this button the way that I normally would. I can't add any ARIA attributes. I can't add any data attributes, so on and so forth. So there's something that we can do even more to refactor this component. So what I really want is I want properties that are intrinsic to the button. And because we're using JSX and TypeScript, JSX has a intrinsic elements type. So I can use JSX.intrinsic elements, use button. Cool. So what am I saying here? I'm saying I want all the properties of my button when I use it to have intrinsic elements of button. And then I want to add my other stuff, which is variant, color, and children, and so on and so forth. So when I go back in here and I see all my options, look at that. I have ARIA attributes, and they're all hard typed. I have context menu. I have all the attributes that normally would be with button in order to make button work. So if we go back to, I'm going to get out of this. So if we go back to our slides real quick, what have we really created? So we created a button that has a class, and that's it. And that's what it is. It's nothing more, nothing less. We have no complex theme providers. We have nothing that's wrapping our component and adding, or nothing that's wrapping our application and adding more weight. We have just a regular button that can be used like a regular button, just with a style sheet and a class attached to it. And that's kind of all we're really going for. We're going as light as weight possible. So when I talked about the prop barrier, it's this is my very rudimentary example here, but basically it's this barrier in between the way that you're using your component and the way that your component was defined that doesn't allow you to use it like an intrinsic element. It doesn't allow you to use it like you were using just a regular button, a button DOM node here, like this. So you can see now that if I use it here, it's just a regular button, but over here, it actually has the style that I want attached to it, and that's important. So let's do a little bit more to refactor this to make it, I guess, a little bit better. So if we use, trying to think what I want to touch on. Let's talk about utility-based components here. So one of the biggest things I see people having trouble with is translating relative units from what design actually wants. So design gives you a pattern, and they want you to say, all right, this should be 24 pixels, this should be 16 pixels. But really, when we deal in the DOM, we want to make sure that everything is relative to the document, because that's what allows people to scale in and scale out and have proper accessibility attributes to their application. So we want the browser to be able to handle that, and we want the application to adjust to it. So instead of using pixels, we want to use rems. So I'm going to go over to my theme utils here, and I'm going to export a constant called makeRem. That is going to take in a pixel size of number, and then I'm going to return pixel size divided by 16 rem. Simple as possible, because we know that the base document size anywhere in the history of the universe inside of your browser is going to be 16 pixels. And we can divide any pixel size that we get by 16 pixels to get the rem that we need. So what does that really mean? So if I say make rem, I can say it's 24. I know that this is going to be 24 divided by 16, which is going to give me the exact same dimensions that I have right now. Same thing with 4 here. So I know it's going to be border radius of 4 pixels. I can do make rem of 4 pixels, and that gives me 0.25 rem. So now I wonder if I can do it in here. I can't do it in here. Let me see if I can pull this up over here. So now if I increase the browser size, these are all relative units and our component's going to scale properly. And that's an important concept when actually dealing with components, is that you want to make it relative to the document size. And again, in doing that in other component libraries, they often have themes that you have to extract props out. And what we're doing is just making it as utility based and as functional as possible. Pure functions are your absolute friend when dealing with CSS and JS. And we could do a couple of other things with colors that I'm not going to touch on because I'm talking too much and I'm running out of time. I'll get back to it if I need to. So that's kind of the things that I wanted to touch on. We could also do a couple other things too, like class name. And if we wanted to wrap this component inside of another class, let's say we wanted to add like class name of Bob. We're not going to overwrite anything in our component. We're just going to extend it on the class down here. And that's important if you want to wrap your components inside your application in styled components or Emotion or another CSS and JS library. All right, sweet. So that's that's buttons. That's obviously the most contrived of the contrived examples as we can get. But let's dive a little bit deeper. I want to talk about inputs, and inputs are notoriously hard inside of React just because a lot of people don't really know all the different attributes that go into it. They don't know the accessibility rules. They don't know the intrinsic DOM nodes or intrinsic DOM attributes. So we often turn to a library to do that, right? So I want to talk about styling an input here. So the main goal that we want is I want to be able to use an input just like I use the button. I want to be able to use it just like I'm using an intrinsic input element. And then I want to create a simple way of styling it in a way that I want, right? So inputs aren't necessarily just inputs. Maybe you use them in a table, maybe you use them outside the context of a table like a search field. But if you're dealing with like a form heavy application, you want a label, you want an error state, you want an active state, you want maybe a hovering state. All that needs to be kind of wrapped up inside of a component, but you don't want to overwrite sort of the main part of the input. So what we're going to do is do, I guess, 2 levels of hierarchy here. So we'll write an input first. So I'm coming all this code here. I'm selfish. I know I added all of this before, but we don't have input text here. So let's do this. Let's do export const input text, and we'll forward the ref. The function input text props ref return input type text, and that's it. Sweet. But we obviously need to give this a little bit more since we're using TypeScript. So we'll do export type input text props, and we'll give it I'll talk about prop namespace in here too because I forgot that earlier. We'll give it a type or input text props of CS for Chariot Solutions of size. We can either be dense or just the default. We'll make it optional. Spelled default. All right. So much like before, we know that this is an HTML input. So we'll provide the generic what it needs. And then we'll do input text props. Cool. We have props. Let's destructure some stuff here. Let's do CS size, do rest props, and then we know the input's going to be a ref, so we can do ref. All right, cool. TypeScript still doesn't hate us yet. That's really nice. All right, class name. Using a small utility here called CLSX, which basically allows me to add different types of JavaScript primitives in, and it compiles it down to a string. It's pretty nice. We'll do class name, and then we'll do class of dense. That's going to be of CS size equals dense. We'll do the same thing with default. Cool. Class name is in. We'll add some intrinsic element or intrinsic properties to it. Not that way. All right, so now we have class name available because that's part of the JSX intrinsic properties. That looks good. We'll spread the rest of the props on here. And those are the rest of the input. And we'll do it at the top. rest of the input props. All right, now we have an input text component. And I believe it's going to be documented over here. Nope. Let's give this puppy a refresh. There we go. Input. Cool. Let's add some style to it, right? So we're going to do const input. We'll do s input text. The style. We'll bring this in from Linaria. So Linaria is a CSS and JS solution that compiles down into vanilla CSS. So there's no runtime dependencies with it. It's actually incredibly nice. Started using it a little bit. I think it's kind of the way we really need to go. There's just too much weight in CSS and JS libraries from a component perspective. You can use them in your apps. I think that's okay. So I'll do height of, we'll add this here. So we'll do dense. It's going to be height of, we'll do make rem, since we want to use rems here, of 36. And then we'll do a default of height rem of, let's say 44. That's a nice hit point for mobile. And you know what? We'll give it a default of default. It's nice how that works. All right, cool. There's our input. Let's add some padding to it. 16. That's going to be one rem. I believe that's left and right. Okay, I was right. Cool. I always forget that notation. All right, there's our styled input. Nothing more, nothing less. Now, much like our button component, what have we done? We've basically said, I have to make this bigger. That's not it. We basically made an input. I hope you can see it, but if you cannot, I'm sorry. We made an input that has nothing more than an input and class. So we can use it the same way that we'd use a button. We have all of our ARIA attributes that we could use. We have autofocus. Here, there's a couple of more intrinsic properties that have to deal with like default value or default check, their value, ID, name, label, all of that. So we have our input text here, and that's great. But like I said before, we want to add some more on top of that. So let's add some more opinions on top of that, right? We can use this however we want, but I think we'll use something that we're normally used to using. So we'll make an abstraction on top of that, and we'll call it a form field text. So if an input is just an input, a form field is going to have a little bit more to it. It's going to have a label. It's going to have an error state. It's going to have a couple of other things too. So let's start out. Forward ref. This is important here. So we're going to do the same thing as our input function form field. So in essence, what we're going to be doing with this component, because we want it still to be a turn, let's do a div for now. Let's do a input text component. We basically want a proxy. We want the form field text to act as an input. So we want the same intrinsic properties. But what we really want to do is we just kind of want to forward all that to the input. So we use the form field text. It's kind of like we're still using an input with a couple of other things added. So what we'll do is the same thing. So do export const form export type form field text, and we're going to get a, we'll do this input text props, because this is going to be treated pretty much the same way. And then we can add a couple of other things that actually matter for the form field, like error. Cast that to a Boolean, or label. So the form field could have a label or not. We'll say it's a string. So what we're basically saying is the form field text is nothing more than an input with a couple of extra things added to it. And we'll add this down here. So input or HTML input element. Form field text props. We're going to get label out, error out, and the rest is going to be rest input text props. So what are we going to do? We're going to forward, we're going to give the ref the input. We're going to forward down all of the rest of the text input props, but we're going to put this over here just for safety's sake. And then we have a couple of options here. We can add, if there's a label, we'll do a label component. I'm not going to style this just because, time. And I want to make sure I try to get through everything and talk about my grids. We'll do label, and then we'll say that the value is going to be label. And then for error, we'll do the same thing, error. And so what should we do? The existence is fine. I don't think we're going to have a label of 0. We'll just do this. Okay. And then error is going to be, we'll do, I don't know, like a div with whatever there was an error. Naturally, you pass a prop in to customize this, but that's kind of what we're looking for right now. Text props. All right, cool. Again, TypeScript doesn't hate us. Let's go ahead and try to add this back into the component library here and see what we get. Form field text. All right, here's our molecules. There's all of our fields. We don't have label and we don't have error, so obviously that wouldn't show. So let's add a label to it. This is an input. I think this is going to show up as an inline block element, so forgive me. There you go. All right, so now we have our label. So this actually is a fully functioning component. We remove the prop buried to the input, and now it's going to function exactly the same way as an input, but we're going to have all the same ARIA attributes and things of that nature. So what does that do? If we go back to our goals, our goals were all we wanted to do. I think I zoomed in too much. Our goals were we just wanted to be able to use an input the way we wanted to use an input, and we want to create a simple way of adding those form properties or those form fields that we normally have in a very easy manner, right? This is as simple of an API as you can possibly get. There's a couple of other things like that we need to pass in, like name, make sure that, if we click on the label, it's going to have like an ID, so we can add that. We'll give ID as text label. Then say down here, label of HTML4, ID. We'll make ID a string and require it. And now if we click on the label, I don't think I saved this one. Text label. All right, well, theoretically, since I'm not moving so fast, when you click on the label, since it has the ID that you need, then it's automatically going to focus the input. So these are the kinds of levers that we can use to take one level of abstraction outside of the input component while keeping it as slim and as trim as possible without adding a lot of different outside context weight, without adding different themings and everything like that. So again, we have some of the more complex use cases all boiled down into the sense of these are the only things we need. If we go look at our distribution directory here right now, here's our ES modules. These are the components we've written. We have 87 lines of components. We have our form field text. We have our input text. They're all hard typed. They're all intrinsic to what you're going to be using, and they're all very, very lightweight. And then if we look at our CSS, it's cacheable. You can load it up in a service worker and you don't have to load it ever again. You can cache bust it if you need to. But, we have 44 lines of CSS and we have 80 and change, almost 90 lines of JavaScript, and we've created buttons, we've created inputs, so we can submit stuff and we can write stuff back to the server and read stuff back to the server. If you ask me, that's kind of really all you need to get up and running, and you've done it in less than 200 lines of code. So that's why it's really important that we practice the proper strategies on building these components the right way. We're gonna have a wonderful time with deploying our application to any environment, to any static hosting site, to any provider, and it's going to be something that we can cache and continue to serve to the customer in a very lightweight manner. All right, so oops, I just said that accidentally. Okay, cool. So we have our form fields, we have our buttons. Let's talk about my favorite. Matt, how am I doing on time? It's 2:10.
Yeah, you're doing really. I still have 20 minutes.
Oh. All right, cool. So I can spend 20 minutes, or I'll spend 10 minutes on this, and then I'll open it up for questions. One thing I did want to point out before we start. was, let's see here, atoms inputs. Let's talk about prop namespacing. So it's not something that's done too often, but let's say that you forward all the intrinsic attributes and make them available inside of your component. You have a mess of properties to wade through. One easy way of knowing exactly what kind of properties you have is to namespace them. Just add a simple prefix that you're going to use all the time. In our case, I'm using CS for Chariot Solutions, shameless plug. And now we know exactly what properties we have, right? We can do the same thing with our buttons, wherever our buttons are. We can say all the variants here are going to be CS variants. We'll go back to our stories. And we can do the same thing with color, since color actually is an intrinsic attribute of the DOM node. Oh, that's too many. Let's say color, 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 CS color. We'll go back up to the prop, CS color. We'll go over to the story. We'll update the attribute. Let's go back to our buttons. Bang. There we go. So with any point of certainty, we know exactly what properties are intrinsic to the DOM, and we know exactly what properties that we customize for the component. It's not like something that's written. It's kind of a best practice that I've developed. But it's incredibly helpful with documenting, and it's incredibly helpful with like communicating just the way that you're supposed to write components. And it scales quite well. So you notice over here in Storybook, you have CS variant, CS color. All right, to grids. Let's talk about grids. This is my favorite. So I'll do the slideshow real quick. So grid layouts are something I think that we're all kind of used to seeing, especially with the popularity of Bootstrap. Bootstrap was kind of the first, I think, library to technically define what like a 12-point or a 16-column grid is. But I think they're actually what I'm calling red herring components. I don't think they should be components at all. I'm thinking that they're components that they had great intentions starting out, but they're not abstractions I think you want to make at the component level, and it gets you into trouble. And I'm going to go back to my history or my issue of context, because context matters. When you get to layout, that's me on my soapbox for a minute. So like I said before, this is what we're used to seeing. It's applied to the global level. One size fits all. You can maneuver it sort of, any way you want. It's feature agnostic. It doesn't matter where you put it. But again, this is devoid of context. In the ether, in the great, webosphere, having a 16-point grid for responsive design is awesome. And you can do a lot with it. But using this devoid of context and trying to square peg round hole it inside of your application is going to bring you into lots of problems. So let's talk about our grid layouts. So from everywhere that I've done layouts are immensely contextual. They tend to be specific to the feature that you want. So let's take product pages, which have over here, you have a product image and a title and configuration points. And then let's take a layout of onboarding, which typically is either done through a mobile device or through like one screen that's pretty much center justified. You have a picture, you go through it, think TurboTax. Those are inherently different layouts that require inherently different types of things. Especially with the prevalence of CSS grid these days, we can talk about our layouts to being contextual rather than trying to fit them all in a one size fits all. So, but within those features, there is an opportunity to standardize. And I'm not saying that you shouldn't break your layout components out into something like the conventional 16 grid method or 12 grid method, but we have to get down to the context that matters. And usually it's done encapsulated inside of a general layout, like a layout root. So here's some of our goals, right? Let's create a layout that is contextualized to fit my features. And we're going to talk about red herrings, and we're going to talk about trying to evaluate different IA. So I'm going to go to this right here, and this is the example I'm going to use. So let's take a navigation bar on the left-hand side. We're going to call the left-hand side a navigation bar, and the right and the top-hand side up here, we'll call it an app bar. So we know we have a grid, 2 columns at 120 pixels give us 240 pixels. I hope that math is correct. And then we have our people from our design team saying, all right, you know what, that nav bar, that should only be 200 pixels. Where do you go from here, right? If you're using a global layout like this, it's not going to mesh well. Like you're going to have to shim it. And again, that gets into the downfalls. is like we're not using the things at our disposal the way that we should be using them. So there's obviously an inherent mismatch. So let's create two components. Let's create an app bar and a nav bar. And let's create a main component. And let's use very simple CSS that actually is a little bit more declarative than what you normally see with like, column, grid, row type components. And then we'll create a secondary layout stacked into it. So I have 15 minutes. I'll see what I can get done in 5 minutes. Take that as a challenge here. So I'm going to open up app. This is our Vite app. I'll go into source. I'll go into main. And I have my internal CSS imported. I'll go to localhost 3000. It's probably going to blow up because, oh no, button. Let's go over to our features here. I'll go to home. Up. CS variant. DS code, give me some autocorrect here. CS color. Again. Go back to the browser. Oh man, there it is. There's our button component. Perfect. Very, very lightweight. All right, so let's create these components here. So we have a main, a main file, what you're used to seeing for React. And then we have routes. So let's create our app bar. We'll go into our components. We'll do app bar. I'm using styled components here. So again, file.nav. We'll just leave it like that for now. And then let's create a nav bar. We'll do style dot header. Let's create a main.css. Since I'm lazy, copy it back in here. We'll do a main. All right, cool. So now I need to create a layout component that is at the root. So we'll do layout.tsx. So we'll do layout root. Export. Let's do this again. Let's give it a div. I'm not really interested in semantics at the moment right now. But if we go back to our picture, we know that we want it to have a left side, a top side, and a center right here. Normally, we would reach for a grid component, but let's try to do it with CSS grid. So we're going to do display grid. We're going to use grid area, grid template areas. We're going to define it. So we're going to say nav bar, app bar. Then we'll do, I hope this is notation, nav bar. I think it's one quote, nav bar, and then me. That's okay. And we'll give it the column. So we'll say grid template. And this is nothing more than a Google search. So this isn't something unwieldy. You just look at, grid components or, grid layouts. So we're defining the areas and then we're defining our columns. So we're going to say our first column is going to be 200 pixels. I'm making it random because they're slick like that. 200. And then we'll say one flex row. And then rows, we're going to do grid template rows. We'll do make rem of let's give it 80 and then one FR. Cool. We'll give it a height and width 100. All right. So that's app. Oh no, I'm sorry. Layout root. I apologize. I might make some mistakes here because I'm rushing a little bit. Let's go back to our main, or let's go back to our app. Let's add in our layout root. And let's add in our app bar. Let's add in our nav bar. Probably not going to get to everything that I want to get to here, but for the sake of argument, we'll just keep going. Okay. We'll just import everything. All right, so we need to give, let's go back to the example. I think I bit off more than I could chew here, but hey, that's life, right? All right, so the idea here is I'll go into it more and I'll add inside the repository just so you have a full view because I kind of want to open this up for questions. But essentially all you really want to do is define an area here. So we'll define like grid area of app bar. Oh, see, look, there we go. We'll do background. Come on, Ray. Okay, so I'm not doing it right, but that's okay. I think I've kind of proven my point in the fact that if we go to our layout route here, we're gonna have a grid like this. And I wish I had like 20 more minutes. We're gonna have a grid like this. And how many lines of code did it take us? It took us 7, I think. Yeah, it took 7 lines of code. So again, do we really need those fancy grid components if we just do a little bit of legwork on number 1, setting our component library up properly, and number 2, just having a little bit of CSS knowledge, right? So again, I don't think anyone's asking anybody here to go in and study what a load balancer is, because I definitely can't tell you. I probably couldn't even spell it. But the idea is if we investigate a little bit, we take a little bit of time and we investigate just how we need to do this stuff, I think what it's going to do is going to free us up from a lot of the conventions, things that were created outside of the context of our application, maybe for a different org or for a different purpose. And we're going to bring all that intelligence back into our application. It's going to be modular. It's going to be built on top of each other. You can compose it, you can abstract it, and you can use it in a way that's really going to be valuable towards the future, towards scaling. So with that, that was a lot of information. Hope you liked it, and thank you. I appreciate it.
Thank you very much, Drew. I, for one, am a little exhausted. I didn't have to do all that typing. I think we have about 8 minutes. So if there's any questions in room B, you got some applause from the Slack channel. Are there any specific questions from any of the attendees? So super newbie question. Those grid template attributes that you were using, that's pure CSS?
Pure CSS. It's defined in the grid spec. Okay. The best resource that you could go to is go to CSS Tricks, Chris Coyer's CSS Tricks, which he just sold for a boatload of money. And just look at grid template, and it gives you a full recipe book of how to go about understanding this stuff. It's newer. The only Safari is the new IE. It interprets the grid spec a little bit differently, but not nearly to the level of variance as it does for the Flex specification. So grid is pretty much the most widely accepted brand new feature of CSS that is pretty much the same throughout all the different browsers, which is, in my mind, is super, super helpful.
All right, we have a question. Can you apply this technique to non-React, non-web languages?
Absolutely. TypeScript and React are kind of the same. They give us like the ability to break that prop barrier down. But once you just use the component there, or once you use that DOM node, you have access to all the attributes. It's just not necessarily as templated out for you. So yeah, it's very easy to apply it. You just you create your CSS sheet, you apply your style to it. You could apply like a hash style on your own. Come up with a naming convention. It could be like BEM, but it's pretty much the same thing. It's just that React gives us the ability to do it a little bit quicker, and TypeScript gives us kind of the bumper lanes to be able to do that. I mean, at the core of it, it's just HTML and CSS. So the same properties can go. It's just this. It's just that we have some fancy tooling to give us those like random hashes.
And at this point, since you can do this so well, and you've done this for a while, I mean, is this your go-to approach even when a brand new project, if you're in proof of concept mode or demo mode or whatever, you do it this way as well?
I will always advocate for this way, partly because I've done this a lot. But, you know, like I said before, your output is a function of money and time. You know, you can do anything that you want with enough money and time, but you really have to evaluate, is that something that is going to work for the project? Short-term project, proof of concept, investor meeting type stuff. Go to the wayside of this, get something out there, get something working that's going to impress someone. And then in the background, take some mental notes about how you're going to go about and refactor this. Because ultimately you're going to get to a point where it's not going to scale the way that you want it to, right? So let's say you get funding. You have 4 designers that come on. Oh yeah, we've been using it this way. They're like, well, we want to completely scrap that. And you say, well, it's going to scrap all my work. Be prepared if you decide to go the weight of a component library, be prepared to delete everything at some point and then restart. So it's all about what the expectations and requirements are of the project. But I'm not saying don't use it, but I'm saying be prepared that you're going to end up locking yourself into a convention that probably isn't so optimal for your end product.
Okay, we have a question here. This might be a softball, or this might be trying to I forget, can you configure TypeScript to error/warn if you union 2 types and properties collide?
Yes, it won't let you. It'll say you're using the, well, no, I believe that the last union that you use, so let's say that you have you use your intrinsic elements to say like color, and then you use color on top of that and make it, instead of optional, required. I believe it'll use the last property that you have for there. So as far as unions go, I think it actually will for unions. I think it'll let you know you can't use the same union. But that's the correct methodology, is to go about using unions for your props, not necessarily unions. I hope that answered the question. My fundamental TypeScript jargon isn't up to snuff as it should be.
I'm thinking it did. Here's some thanks. Thanks for teaching. It's okay to try and build our own components.
Yeah, you can do it. It just takes a little bit of time. I promise next year I'll come back and tell you how to configure the library, because that's a whole other 3-hour talking and stuff. So I will mention, Matt, that this is on Chariot's GitHub. So once I'm done with this here, I'll publish it all up. I already have some pretty crazy readmes on how the library was set up. So you can go in, check it out, peruse the code, steal it, use it, apply it. It's all free for you to use.
All right, here's someone is confirming from firsthand experience with Drew that you don't need a big library for layout. That was from Matt Gilbride. You may remember, or not, I don't know. CSS tricks, Flexbox, grid sites is all you need. Yeah, you mentioned the CSS tricks. Are there other resources that you would recommend for someone that wants to start down the path to getting to the point to do all this kind of stuff?
MDN docs.
Okay.
Use those as much as you possibly can. I think they actually just went through a pretty big revamp, but MDN is an invaluable resource. That's not what I wanted. It's an invaluable resource for getting started. So they have different courses that you can use, like Learn Web Development, and they walk you through fundamentals, CSS first steps, like how is it structured, how does it work. I honestly feel that if you're going to go anywhere for free, CSS tricks is #1. It'll give you some good snippets and sort of cheat sheets. But MDN is probably the best resource that you can possibly use, and they're enhancing as time goes on too. So.
All right, we got about 1 minute left. There don't appear to be any last minute questions. So I want to say thank you very much, Drew, for presenting today.
Great.
And for everyone in attendance, thank you very much for coming to ETE. And if you got anything else, final words, Drew?
Nah, thank you. Appreciate it. It's been fun. I'm exhausted. I'm going to go take a nap.